Today is 11.1 and we're going to be solving absolute value functions. So today you're going to understand what an absolute value represents and you're going to solve absolute value functions. So here's a few ways for us to actually describe what it means to have the absolute value of x for any real number x. Now one of the common ones is we say that the absolute value is going to be the distance from the real number x to 0 on the number line. So notice if I say the absolute value of -5, well, the distance from -5 to 0 is 5. The absolute value of +5, the distance from +5 to 0 is 5. Now another way to define it is by saying the absolute value equals the square root of x squared. So if I said 5 squared is 25, the square root of 25 is 5. Well, the absolute value of 5 is 5. -5 squared is 25, the square root of 25 is also 5. So that's why the absolute value of -5 is going to be 5. Now, this definition you're going to see more in applied sciences. You're not really going to examine it yet, but just know that that is another common way for us to do it. Now, something we're going to look at a little bit more tomorrow is how we transform this absolute value into a piecewise function. And so we're isolating it from the negative possibilities and the positive possibilities. And so because we're isolating it with these negative and positive possibilities, we're going to be able to set up certain equations and be able to solve it for that. So looking at the different properties, if I say a, b, and x are real numbers and I let n be an integer, then we have a few rules here. The first is a product rule, and this just says that if I multiply two values within my absolute value, I can break them apart into two separate absolute values being multiplied. The power rule says that if I have a value to some power, that's going to be as if I just isolate that absolute value and take it to a power. And then the quotient rule is if I'm dividing two numbers and it's inside of absolute value, you can break it apart into two separate absolute values. Now these equality properties, these are going to be the ones that we're going to be using to solve today, so these are super important. There's basically three scenarios. It equals 0, it equals a number c that's positive, and it equals a number c that's negative. And so that's why we have c is positive and c is negative here. And so the idea is if x equals 0, then you just solve it, x equals 0. If c is positive, for this given absolute value, you take whatever is inside the absolute value and you set it equal to that c, and then you take the negative version of what's inside that absolute value and set it equal to that c. And then if my c is negative, then it has no solution. So our first one here, this says absolute value of 3x minus 1 equals 6. So the first thing that I want to do is I want to isolate my absolute value, make sure that that's by itself, because once it's by itself, then I can use any of these three definitions here. And so now it looks like it's this definition. It's going to equal a c where c is positive. And so I want to break this apart into where it's inside the absolute value equals c, and then the negative version of what's inside the absolute value equals c. But then what you do for the next step immediately is you divide everything or multiply everything by the negative, and so this becomes positive and this becomes negative. Now you don't have to do it that way, but that's just the way that I do it. So now just solving for this, so I'm going to add 1 to both sides on these both equations. Then I can divide both sides by 3 on both of these equations, and so that's how I get x equals 7/3 and -5/3. For this next one here, this one's going to be a little bit more abstract, but still good to look at it. Because this is a variable, we have to assume that my c is, it's going to be this case here, that my c is quote-unquote positive. Just because there's a chance where I can plug in a value for x in which it makes it positive. And so that's where we have to make that assumption, which is why we're going to use that case. So it says take whatever's inside the absolute value, set it to the positive version, whatever's inside the absolute value, the negative version of it, set it to that c. And so it is isolated already, so we're good there. And so my first one, what's inside the absolute value equals c, and then my next one is going to be the negative version of my absolute value equals c. Now I just divided both sides by the negative, which is why it looks like that. And so now solving for these, this is a quadratic equation, so I want to bring everything to both sides. So I distributed the negative here, I subtracted x on both sides here, I distributed the negative here, so that's how I got the negative x squared plus 6. And then I added x squared to both sides, subtract 6 to both sides, and so I get x squared minus x minus 6 equals 0. and then x squared plus x minus 6 equals 0. Now both of these, because we can factor them, so factoring this will factor into x minus 3 and x plus 2. This will factor into x plus 3 and x minus 2. X minus 3 and x plus 2. X plus 3 and x minus 2. I know, they're close, but just understand that they're not the same. So my solutions are going to be 3, negative 2, negative 3, and positive 2. But now we have to test these. And the reason why we have to test it is because this is a variable, and we said we have to assume that it's a positive c, but what if I end up getting that negative c, which means it would be no solution. So I have to test them to see if they work. So I plugged in 3 into my equation, I plugged in negative 2, I plugged in negative 3, I plugged in 2 into my equation here. Now if you notice on this one, 3 squared is 9, 9 minus 6 is 3, well absolute value equals 3, so that works. But on this one, negative 2 squared is 4, 4 minus 6 is negative 2, well the absolute value negative 2 equals positive 2, so positive 2 does not equal negative 2. And the same thing happens here, so those cannot be part of my solution. So I have to get rid of negative 2 and positive 2. So my only solution is going to be positive 3 and negative 3 on this one. So now let's practice a couple of these. So if I wanted to solve this one, we have to isolate my absolute value portion. So I want to isolate that. So I get negative absolute value of x plus 5 equals negative 2. Divide everything by negative 1. I get the absolute value of x plus 5 equals 2. So now using my definition here, we say what's inside the absolute value equals c. Then the negative version of what's inside my absolute value equals c. So then solving for this, minus 5 on both sides, I get x equals negative 3. And then divide both sides by negative 1, I get x plus 5 equals negative 2. And so if I minus 5 on both sides, I get x equals negative 7. So my answers are going to be negative 3 and negative 7. On this next one here, if I add 5 to both sides, I'm going to get 3 times the absolute value of 2x plus 1 equals 5. Then divide both sides by 3. Now it's going to be step 2, so applying the property. So I'm going to use this property here because my c is positive. So I'm going to, what's inside the absolute value equals positive c. The negative version of what's inside my absolute value equals c. So now solving for this one, minus 1 on both sides, I get 2x equals, so if I'm on a minus 3 over 3, I get 2/3. Divide both sides by 3, I get x equals 2/6, which is the same as 1/3. Now on this other one, I'm going to just divide by the negative, so that's going to become a negative 5. So I get 2x plus 1 equals negative 5/3. Now if I minus 1 on both sides, I'm minusing 3 over 3, so I get 2x equals negative 8 over 3. Divide both sides by 2, I get x equals negative 8/6, which is negative 4/3. And so that's also going to be another one of my solutions. So my two solutions are going to be 1/3 and negative 4/3. So looking at this example here, if I minus 4 on both sides, right, I have to isolate my absolute value. I get the negative absolute value of 5x plus 3 equals 1. Divide both sides by negative 1. I get 5x plus 3 equals negative 1. Now here's the issue. My c is negative, so therefore it's going to be no solution. We have to catch that. Make sure that you recognize that it's going to be no solution when we do that. Now what happens if an absolute value equals an absolute value? This was a really good question that brought up, so I wanted to include this in the lesson. And so geometrically, if the absolute value of one function equals another function, then we can make the assumption that f of x equals g of x, or f of x equals the negative version of my g of x. So I can make the assumption x equals g of x, or x equals the negative version of my g of x. So now I solve for each one of these. Well, these cancel out, so I get 0 equals negative 3. Well, that doesn't make sense, so that can't work. And then so here, if I distribute that negative through, I get x equals negative x plus 3. If I add x to both sides, I get 2x equals 3. Divide both sides by 2, I get x equals 3/2. And so that would then be my solution. Well, this concludes our lesson, so if you guys have any other questions, please leave them in the comments.